What's happening there, YouTube? Genji here, and welcome back to another episode of StarRupture. Now that we have completed one of the 5 corporations and reached the top of the manufacturing tree, all that we really have left to do is to circle back around and create a few additional items for each of the other 4 corporations to hit their top level item for their own manufacturing trees. So to start off, what I've done is I've disabled our, I think, top 2 manufacturing items for moon energy, and that was our RTS generators and our cyclotron. So both of these machines have been turned off, and as you can see, this entire factory has eventually gone quiet as each of the machines in turn backs up, and their output buffers and their storage is completely full. So our RTSCs are full here, which allows everything that goes into making RTSCs to back up and fill up. So this factory, over the course of, I want to say, 2 or 3 ruptures while I was running around shoring things up, has completely backed up. So we're stocked up with materials to work on our other 4 corporations. But let me go back and show you what I was actually working on during those couple ruptures. The first thing was storage. I've gone back and I've added as many V2 storage depots as I can to add additional buffering capacity for all of the materials that are currently not being used while we work on readjusting and refactorizing our high-end manufacturing for other products and manufacturing tracks. So while we're idle, I don't want the factories to be idle, or at least I want them to build up as much of a backlog as possible, so that when we do switch on our new factories, we have a ton of extra materials and buffered items to work with. So I've gone back to all of our higher end factories. I didn't go all the way back to like smelters and plates and that sort of thing, but basically everything in our mega press factories, in our compounder factories, in our assembler factories, and then in our high-end Atlas base factories for our constructorizers and everything, probably about halfway through the manufacturing tree and beyond, I have added as many storage depots as I can. Not everything was in a position, like some stuff was just buried too deeply inside of a factory to properly buffer it or to squeeze the size or the footprint of a V2 storage depot in there. But I threw prettiness to the wind and just kind of stuck them wherever they would fit or where I could feasibly get rails into them. In some cases, I left the original depot in place and then just added a V2 storage depot in line. I'm actually not sure. Oh, this one had a couple of extra pumps that wouldn't fit. Okay. But yeah, I threw rail beauty to the wind and just went purely for function over aesthetics, and so wherever we could fit in some extra buffering, we now have extra buffering, and hopefully, I mean, if you really break down the numbers, at 1.07 million data points or corporate points for each of the other tracks, and getting 1,000 points per top tier items, you only need to actually manufacture 1,070 of the last item for each manufacturing track. So even if we're potentially underproducing items so that our final facture is not operating at 100% efficiency, it's possible that we have enough backed up materials that we'll have those 1,070 products manufactured before our buffers run dry. At least that's the hope, because I don't know during our refactoring if we're going to actually hit the entire manufacturing tree so that our last item is running at 100, or our last facture recipe is running at 100% efficiency. I just want to be able to manufacture enough to meet the quota. I don't necessarily need a 100% efficient factory. So let's claim our final reward from Moon Energy, which is 100 quartz ore. And then let's pick another corporation to work on. I've actually already broken this down. I mentioned this in the last episode, but the next easiest corporation to work on is going to be Selenian Corporation, because we only need to manufacture 5 additional items in order to meet the requirements for the end tier item for Selenian Corporation. But to start, I think we're going to get a Nanofiber factory set up, because there are a number of other manufacturing recipes that are going to go into the other corporations that also require nanofiber. So it's going to be a good place for us to start, and it's relatively simple to make. Our target number for nanofiber is going to be about 48 per minute, which is going to require 3 compounders. Fortunately, most of the materials that we need to feed these compounders are stuff that we already have on hand. So we have liquid helium that we set up in the last episode. We have, well, we don't have wolfram wire necessarily, but we do have extra wolfram bars on tap. We're going to need about 48 per minute for wolfram wire itself, which is going to also require some wolfram powder at 16.1 per minute, but all of that can be easily fed off of a single dispatcher's worth of wolfram bars. What we are going to need the most of, though, is tubes. We're going to need 3 Fabricator V2s worth of tubes So the majority of this factory is actually going to be towards manufacturing tubes, which are then going to feed into our compounders. But overall, this is going to be a relatively painless factory. So let's go find a good location to house this. And I think we have the perfect spot right here next to our plateau base. There's a smaller mesa down next to one of our tertiary calcium bases. Let's head down here now without breaking our legs. And this should be enough area. I don't know if we'll fit all of our Selenian Corporation manufacturing in here, but we have at least, I don't know, maybe 6 factory lines worth of space available here. So let's start with a base court. That doesn't overlap with any of our existing manufacturing. Right about there. That way it doesn't get in the way of any of our lines. And we'll start here on the top left. So the first thing that we're going to need is 3 Fabricator V2s producing tubes. So let's put this on this far end, and let's point them in this direction. That way we can feed these directly into our next manufacturing line. And I'm going to start these down towards the end. Let's say about here. 1, 2, and 3. Because we have some additional things that we need to set up before this. We're going to need 2 receivers. Cargo receivers pulling in, let's say, titanium plates and gothite ingots. And then before we get to that, we also need to manufacture wolfram powder. So let's put in a furnace V2 facing this way. We align this to the back. Right here. That way this gets spit out and then joins the rest of this. And to feed this furnace, we're also going to need another receiver with our wolfram bars on it. So let's go to cargo receiver. We'll buffer it. We need to buffer, well, yeah, we need to buffer it because this is also going to be feeding another manufacturing line for wolfram wire, right? Let's lock our Z. I guess we can push this back 1. It won't be the end of the world. Drop in some storage depots for buffering. There's our wolfram bars. These will be for titanium sheets and for gothite ingots, something like that. And then I guess we need to put one more here just to even things out for our wolfram powder. Let's do 1, 2, 3. This will be for wolfram bars. And this is going to feed rail support. Actually, let's put a rail connector on this because we're going to have to break these bars off into some more manufacturing once we get a little bit further into this manufacturing line or into this factory. And we'll put these, we'll run this rail to here. I like that curve a little better. Okay. In the back, we're going to need to set up our distribution rail. So we'll start a rail support here. We'll modulate this way. And I guess this sticks out a bit far, but that's fine. We'll just angle this a bit. Like this, make a little S curve. There we go. That probably should have been a rail modulator and not a rail support, because we need this to continue. So rail modulator here. Yeah, might as well continue it. So this to here, and then finally a rail support on the end. I'm going to start at the beginning. We're going to have wolfram powder, then to our titanium sheets, then to our gothite ingots. Bring it all together. Now we can curve it. Break it off. I just noticed I don't have these spaced correctly. Not that it's a huge deal, but it's early in the build. We shouldn't start slacking off this early. Just so that they all have the same curve going into the machines. There we go. And then we just need a little bit of power. And we'll worry about our output afterwards because we're going to go probably directly into our next manufacturing line. So let's drop down a wind turbine V2. I don't know if we necessarily need an entire 8,200 power, but if we do, we know where to get it. So let's put this here, and we're already... Oh, I think I might have put this over the line. Yeah, this line here is for that one. Okay, so let me move this to the other end of the factory. That way we're not overloading our existing factory. Put this wind turbine down on this end. Let's go out of the way for now, just in case I need to put something here to distribute these tubes. Oh. There we go. Let's keep that level. Okay, so we're powered up. So let's set up our recipes and our receivers. So we know this is going to be one of our available Wolfram bars. This will be W bar RX11. Wolfram bars. This is going to be producing Wolfram powder. So this will need to be Wolfram powder storage. Then we're going to have titanium sheets. So T-sheet TX7, T-sheet RX7. This will store titanium sheets. This is going to be gothite ingots. We'll grab gothite ingot TX12, gothite ingots RX12. Let's store gothite ingots. Now our fabricators. We're making tubes. Gothite ingots check. Titanium sheets check. Wolfram powder check. Here it comes. Tubes. And tubes. Here comes something. Here's our gothite ingots. I see sheets. We're fabricating. And there we go. So these are producing what? 240? This is 8 times 2, so this is 30 cycles per minute. 8 times 30 is 240. Yeah, so this is actually producing more than a 480 item rail. So we will need to divvy this up a bit, although we don't need the full output. Even our partial output that we need, which according to Rupture Planner is 518 per minute, is going to exceed the capacity of a V3 rail. But we'll worry about that when we get our next machine set up. So after this, we're going to need to produce some Wolfram wire. So we're going to need 2 Fabricator V2s worth of Wolfram wire, which we'll set up next. We want to put these on top. I'm just going to have to find a pillar position that'll allow us to put these on top, which I think will probably just be in the front of these receivers. If I put these at level like so, pillar supports, 1, 2, 1, 2, 1, 2. And we're going to drop Fabricator V2s on top, space out by 1. We're offset by 1 from the receivers, which also just so happens to be in line with our rail distribution, which is what we want. And in fact, I think what's going to make this a little bit easier is if this was a rail modulator, so it's pointing in the same direction like this. That way we can bring this out, bring this straight, and then we can bring this up into another line up here. Auto-saving. There we go. So let's make this a rail modulator. Top. Lock our Z. We'll make this a rail support. And then this can just come straight up. Bring it through. Like so. And I believe the only input into this is Wolfram bars. Let's see. Wolfram wire. Yep. Wolfram bars. Wolfram bars. We'll feed these in here. There we go. There's our Wolfram bars. So let's gather our output. one, and then a rail modulator facing this way. Collect the, this direction. Collect these together. And there we go. So we'll need to bring these forward. So we can either do that with a receiver, so that we can just drone receiver these up and then down into the next assembly line, or we could put these into a multi-rail 3, which may work, or a multi-rail 5. Multi-rail 3 is probably okay, but we have the 5s now. There's really no reason to not use the 5s. So let's do that. Let's bring these around with a rail support. Like this. And then, like, let's see, our line is going to be here. So let's bring these to here, platform, and then spin these like this so that they're on the same plane as the rail that we're going to be collecting for our tubes. We'll bring these together, bring these down onto our multi-rail 5, and then we can loop this around and then bring these directly into our compounder line. Let's hook these rails up. Curve. There we go. So each of these is producing 240, so we know we can bring together 2 lines. We'll rail modulate these 2 together. This is 240. Oh, what? How did that happen? We wanted it this way. There's 240 and 240, and if I'm not mistaken, these are 120 and 120. This is 4, so that's 15 times 8 is 120. So these together are 240, which is fine, and we just need to figure out how we're going to bring these together onto a multi-rail. Something like this. Can I go from here to here? No, I need to space this out 1. Otherwise, we're going to bonk into the top of this rail modulator. So from here to here. And then from here to here. Of course, that's in the way. I guess we can just go straight. Well, let's just swap it. Because when we rotate this around, I kind of want this to be on the inside, because then that will be on the first rail going out when we loop this around into our compounders. I want this here, and then I actually want this to be on our second line, so we'll put this on our third line. Like this, which gives us a little bit of extra room here anyway for bringing our rails together. And then we're going to grab another multi-rail 5 support. And I think this may actually need to go forward one, because I need to bring this down and under to make this work. We'll do this, and then we'll do this down 1. This will go into here, and then up into position 2. And then we'll bring this forward 1 and 3, like so. There we go. So now we have 480 tubes, 240 tubes, and then 240 Wolfram wire. So the only other input into this we're going to need is liquid helium. I may need to set up a receiver for that. I know we're manufacturing extra liquid helium, but I don't think I set up the dispatcher for it. But we'll worry about that in just a second. Let's rotate this around. Let's lock our Z. I'm going to go like this, and then like this. That way we get our 1 tile gap in between our manufacturing lines. And we'll do inside out. Nice 90-degree bends. And there we go. And like we said, we have 480 tubes, 240 tubes, and then 240 wolfram wire. So we're gonna need a cargo receiver. Lock RZ, we're gonna bring this back 1, 2 to make room for our buffer. And then we're going to need 3 compounders. These are going to go forward so that they're in line with our storage depot. 1, 2, and 3, just like that. Is that right? Yeah, that's right. Okay. We have a gap of... Oh, right, this sticks out a little bit extra. That's fine, though. That's, I guess, one of the reasons that I leave an extra space in here is just in case of situations like this where something has to stick out a little bit further. So we do have still room here for bringing our rails through. So let's put rail V3 into here. And we know we're going to need probably 3 different inputs, 1 for each material. So we're going to need our rail connector, and we'll do maybe our wave setup. We may have enough space because these are so wide. There may be enough space for us to do a rail modulator setup, but let's see. If I bring this down 1, 2, we'll bring this up 1, and we'll bring this up 1, and if I duplicate that, actually let's have to go back 1. We're past our input. Rail modulator 1, 2, 1, and 1. Okay, and then starting here, 1, 2, 1, and 1. Can I wave this around here? I cannot, but all is not lost because we do have the modulator 5s. I'll leave these up just to test the modulator 5. So if we do 1, 2, 1, and 1. Can we wrap a modulator 5 around? We can do a modulator 5. Maybe? Maybe? Yes. Okay, so modulator 5s are going to clean up our lines, our distribution lines, a whole bunch. So actually we'll leave these here. We'll convert these from 3s to 5s. Because they stick out so far. 1, 2. 1, and 1. There we go. And then I'll leave this for now because this might just be able to catch our multi-rail 5s and then just go directly in without needing to modulate it. So let's set up our distribution first. So we'll send these through. And I guess just for consistency, we can do this from the outside lane. And we're going to need to bring this in to where? I guess do this as a rail support. I just need to know what height to set this at. I guess we'll do regular height. We're going to grab our output from our liquid helium buffer, and we'll bring this into our top rail here just so it's level. There we go. And I need to get, well, actually, you know what? Let's bring this down because this is going to get in the way of us getting stuff from this multi-rail 5. So yeah, we'll make this the lowest rung. Rail support, 1, 2. Lowest rung. It's going to be way easier to go over the top of this and try to bring this down underneath it. And then we'll grab our tubes, 480. Put this, we want to go directly in like that. Let's check our recipe. How many of these can we feed off of this first line here? So if we manufacture nanofibers, this is 20 tubes per cycle, 6 cycles, so that's 6 seconds, so that's 10 cycles per minute. So each one of these is going to be consuming 200 tubes. So this is actually going to be a little bit weirder of a distribution. You're going to have to do a little bit of rail balancing here. Well, no, not necessarily, because if there's 200 tubes, this would be 400 tubes. We have 480 on our first line, right? So that's going to be, okay, that's going to be way easier. So it's just going to be 2 on our first line, and then this one's going to get the second line, and we'll be golden. Okay, never mind. Worrying over nothing. So that means I do need to get this second line of tubes past all of this somehow. Which we can do, I guess if we bring it, our very bottom rung is available to do that. We can do a multi-rail 5 on the very bottom elevation, like so. Bring this all the way down. And then we'll go past this to here. And catch this extra line of tubes. So let's see. We're going to have Wolfram wire, which we can bring up into our top line. And this should be everything that we need here, as long as we can actually get these into the machine, which we cannot, of course not. That would be too easy. We can do 2 and 3. Let's see, first I need to get this. Can I bring this all the way through to here? I can. Okay, I just need to know how much space I have to work with here. So we'll grab tubes, we'll bring this into the outside lane here. This will pass our tubes all the way past these first 2 compounders to here, so I'm not worried about that. I just need a method to get this FAR modulator 5 into this machine. So what if I catch this on this side? We bring this down 1, 2. There's enough space in here to put this facing in this direction. Can we get a rail from here to here? We can. Can I get this from here to here? I can. It's a little ugly, but it works. So then we'll do this in here, and we'll do this in here, and there we go. All of this to get straight rails. Okay, so this is going to be liquid helium. We've got liquid helium through this connector into our machine, and then this is going to be tubes, and then this is our Wolfram wire, right? Okay, we're set. So let's do the same thing here. You know, this is going to be input number 2. This is going to be input number 1. We're going to have to catch this rail at the bottom. I guess we could actually catch it because we don't need to pass anything forward. We don't need to do it at the bottom on this one in particular. We can do this at the same level, so this would go forward to here, and then this will go up, right? So this is our liquid helium, so this will actually need to go forward, but it'll be from this outside rail, right? Oh no, we do need to bring it forward, never mind. Undo. At the bottom, we'll repeat this from here to here, and then into our machine. Okay, so there's 2 machines set. We know we have our tubes here. So we'll bring this into a rail support. 1, 2, 3. Well, if we do a little bit past, it's going to be a little bit easier, right? Because the curve on that far one is a bit too much. So if we do bottom rung to here, we're going to need our liquid helium, which is second from the bottom. That's coming into this. We're going to need something to catch this. It's down 1. Down 2. Right, our liquid helium is this line right here, so it's coming to this connector, passing through to this connector. So this is going to need to go from here to here. And then this line is our Wolfram wire. That's going to go to here. We'll catch this. Rail support here. And then just send each one of these in. 1, 2, and 3. And there we go. Okay, so let's set... Oh, this is already set. we're making nanofiber. And nanofiber. There's tubes. There's other tubes. Beautiful. Okay, now let's see. I don't suppose I happen to have a liquid helium set up. I don't. Okay, so let's take a quick trip over to our liquid helium base. Okay, so here in our compounder bay, I'm looking at our ratios here. We're producing 400 per minute across our existing compounder V2s, right? This is 3 seconds. That's 20 cycles per minute. We're producing 5. 5 times 20 is 100, times 4 is 400, and we're going to need 120 per minute to make these nanofibers, which is like the output of at least one of these entire machines. So I think what I'm going to do is, we know that we can support up to 8 of these, and I only made 4 because I didn't want to have to do, I guess, rail balancing, and oh yeah, because I kind of ran out of space here on the edge for these as well without having to move our dispatchers forward. But what I do have room for is to put an additional one on top. So if I come and we put these at this level, we'll lock our Z. And if I put, let's say 4, is this going to be enough pillars in here? We'll stack 4 pillars on top of each one. 1, 2, 3, 4. Copy this. Lock our Z. Spin this around. And there we go. So this is going to be 100 of our 120, and then I can just siphon 20 off of our existing production. And as you can see, I have added a few more V2 storage depots here for some extra buffering of liquid helium. So we'll extend this forward to here. From here to here, break this off into here. And I think these are relatively low draw. This is 1, 1, and 1. At 20, 3 times 20 is 60, times 4 is 240. So we have plenty of extra space left here on this rail. We can fit a 5th without having to break this into 2 separate rails. I just need to get up here and set our recipe. There we go. We're making liquid helium. Here comes our materials. We're compounding. So from here, let's either stack or run a new distribution line. I might take this directly. We'll dedicate the entire output of this one machine, all 100, and then modulate that together with 20 that we're going to siphon off from one of our existing lines somewhere. Adding these additional storage depots is going to allow us to pull from some more locations. So let's see. We'll put an additional dispatcher here, but back 1, because I am going to need to put a rail modulator facing this way. This is farther up, which is fine. I just need to find a route to get a wire, or to get a rail from here to here, perhaps. And then we'll wrap this around, the output to this around the back, rail support. Bring this up, lock our Z, take our output. We'll swing this around, bring this to this edge. And I think we might have a clear shot down to that. We're in the end game here, so I'm just kind of stringing things where it'll fit just to get across the finish line. So we'll bring this down into our modulator. We'll grab one rail out from here. There we go. And I'm hoping that it's going to prioritize this, but we'll have to see, because this is equidistant, but this is going to be a longer rail, so actually I think is going to draw more from here first, which I don't like. And I don't actually know how to prevent that. This game needs like the equivalent of a rail resistor that you can put in line with a rail, like a rail support, and it has like a configurable delay so that it'll prioritize like drawing from this until this is empty, and then it'll pull from this, rather than if I were to hook this up right now, this rail is the shortest path, so it's going to pull probably all of its materials from this and probably never even touch this until this is drained, and I don't want that because it's going to siphon away our materials that needs to go into our other dispatchers. So what I may have to do instead is, instead of going directly into this dispatcher from here, I may have to put it into this. Or I just add a completely new machine, and then we combine the outputs of this. And then instead of taking the extra from our existing manufacturing, we just send the extra from this manufacturing into the rest of our manufacturing. So we'll combine the outputs of these two machines, so that'll be 200 total, of which we need 120. We'll feed 120 of that into this dispatcher, and then we'll send the rest into our normal collection. And we'll bring this forward. This is 4, 5, 6 of our 8 that we can support with our incoming materials. So we'll set, where am I? We'll set this one to produce liquid helium. Here comes our materials. We'll put some more collection on the back of this, a rail modulator. I can't. There we go. Get out of here. Spin this way. Lock our Z. Not stable. Incredible. Let's make some stability. We'll drop a supported platform there. Bring this up 4 pillars. Support a platform. That'll have to do. Rail modulator facing this way. Now we can take this 100 and this 100. There, we have 200. So to make this rail routing easier, I'm going to delete this guy, and we'll line this up so this can come around this way, right? Let's do a rail support here, and then a rail modulator here. That way we can do one of these into our dispatcher, and then one of these can go into one side. Maybe we do... take this out. This is our final feed to go into our original depot. If we do this instead, we can take this output into here, and then we can do one of these straight out. I might have to do this from the outside. Let's see. This dispatcher is going to be more important, so let's get this down first. Rotate this around. Send it back to here. Can we go straight in? We can. I don't know if I want to. Let's do a rail support here. Oh. Then in. And then we can take our extra 20, feed this into our normal system, and there we go. So. Let's make this collect liquid helium. We'll call this liquid He3 for nanofiber. Sure. Okay, let's get back. Okay, let's finish this off. We're going to turn this receiver into liquid helium 3 for nanofiber. We'll set this to collect liquid helium. There it is. We're making nanofiber. And we're replenishing fast enough. Let's just make sure our last one is doing the same. I think so. Okay, so let's collect this into a storage depot V2 on the far end, right here. Rail modulators here and here, and then rail supports here and here. Send it through. Feed this. That's fine. Collect nanofiber. And I believe we need this in 2 locations. We can check that at StarRupture.tools. It's one of the few places I've seen that'll actually show you what each item actually goes into manufacturing rather than just telling you what you need to manufacture it. So if we scroll down to crafts, we can see that this nanofiber is going to be used in biofilament, condensers, and nano syringes. I don't know why condenser is listed twice, maybe 2 different recipes from 2 different manufacturing buildings, but it's 3 different materials and then some things that were data mined that are not in the game yet, I'm guessing. So we're going to need 3 outputs or 3 dispatchers for this nanofiber. So let's set up a V3 rail, multi-rail 3. I think I will actually put this into the side because I want to use these 3 outputs to send this into our dispatchers. Let's get this here. We're going to need a rail support to bring this back one around. Let's delete this rail right here after this goes through. There we go. Rail V3, we're going to send this into this backside. Perfect. This is going to come around, and then we're going to take 1, 2, and 3. Dispatchers. I guess we can do these just to save some extra room here. We could go above our compounders, or we can put them on the outside here. That might be a little bit easier. So we can do something like 1, 2, and 3. And we'll break our first one off here. We'll copy this, 2, and 3. Bring this one forward. Bring this one forward. There we go. So this is going to be... Where are we? Right here. Nanofiber for biofilament, right? There's number 1. Nanofiber. Nanofiber for condenser. Nanofiber. And then nanofiber for syringe. Confirm. Now, the amount that we're producing is not enough to run all 3 of those factories simultaneously, but they're on different tracks. Like, we're not going to need to be manufacturing nano syringes at the same time as manufacturing condensers because those are on 2 different corporate tracks, right? Nano syringes are going to be for Future Health, and then like condensers are going to be for Selenian Corporation, which we're working on right now. So basically, these 2 will likely not be running at all, while this one is sending nano syringes to our condenser line. And once we finish off Selenian Corporation, we can just not use this anymore. We'll turn off the machine for condensers. And so these dispatchers that are going to our other factories will be the sole users of these nano syringes. So for right now, we'll let this build up our buffer of nanofibers. This is what I meant to say. We're building up our buffer of nanofibers. And yeah, let's go get to work on our next factory line. So the next material we're going to need to manufacture that we don't yet have is scaffolding. So this is our manufacturing tree for domes. Scaffolding, we're going to need 3 constructorizers producing 15 per minute, and that's going to be pulling down 30 uber filament per minute, 15 gothite lattice per minute, and 15 plastic dust per minute, which is going to be fairly simple because we already have all these materials available. We just need to get these routed into dispatchers and then into constructorizers. So let's go visit uber filament and plastic dust are in our Atlas field base, and then gothite lattice is in our mega press base. So let's go to those. We'll set up some extra dispatchers, and then we'll come back here and set up our 3 constructorizers. So here's our gothite lattice in our mega press base. As you can see, we have 1 V1 storage and 1 V2 storage completely full of gothite lattice. These are currently feeding 2 dispatchers. I want to say this is for pseudo rubber insulators and for uber filaments. So we do have 1 more output. Yeah, we should have 1 more output, although this is feeding directly into that. That's unfortunate. But right now, this is not being used at all, or we can grab... Yeah, we can grab 1 more output off of the backside of this. So we'll put another dispatcher somewhere in here. We'll put this way. We'll put this right here. We'll grab 1 output into this. We'll call this gothite lattice 4 scaffold. Now, if we look at the actual build chart for domes, it does say that we need 5 full mega presses worth of gothite lattice to feed the demand for the last product, the dome, and we only have 3. However, the other 2 ingredients that we're currently manufacturing, pseudo rubber insulators and uber filament, we also have 2 full storage depots of those each, so I don't know if we necessarily need that much demand, considering we already have most of that demand not only covered, but already manufactured and waiting for use. So I'm hoping that between our buffered items that we have, we're going to have enough spare draw from our gothite lattice to be able to feed our demand for scaffold. If not, we'll cross that bridge when we come to it, because we do actually have, from what we're outputting in our receivers here, we do have enough material left over to fuel 1 more mega press making gothite lattice without going over on our budgets of incoming resources. But again, I don't know if we're necessarily going to need that, so we'll cross that bridge a little bit later. Speaking of which, uber filament is here in the back left corner of our Atlas field base. I did upgrade this to a storage depot V2 in between episodes, and it is fully filled along with everything else in our Atlas field base. So we have 2 extra outputs available here. So what I'll do is convert this from a single rail support to a multi-rail. That way this can still stay connected to whatever it is that's being manufactured with uber filament here. Next I need to put this out 1 more, because we need to bring something else in here. Actually, I may not be able to get another output from this. I can get this, which we'll have to do. So if we rotate this way and bring this down 1, that'll do. Okay, so we can actually put this back where it came from. We'll put this here. We'll bring this up, and that'll give us enough leeway to stick a second dispatcher right here. No, with a multi-rail support. Multi-rail 5. And we'll grab our second rail, bring this to here, loop it out, put extendable walkway back in for neatness. Go there. And this will be uber filament 4 scaffold. Close enough. Uber filament. So this is actually going to require quite a bit of gothite lattice, because this gothite lattice goes into making uber filament, which also goes later on in the manufacturing process, goes directly into making domes. So we're tripling up on the scaffolding, or on the on the gothite lattice. At any rate, that should be all set for now. So let's go take care of our plastic dust, which is buried somewhere in here. I want to say it's through here because I think basic fuel is a component of plastic dust. This looks like the right line. Here's plastic dust. This is our extra storage depot V2 for basic fuel that I dropped in. Aha, here you are. Oh no! I only have a V1 storage for plastic dust. This could have been building up in the background. How difficult is it going to be to upgrade this? Not terribly, I don't think. We have a spot right here, just so that this can be running, building up storage in the background while we work. We'll convert this to a storage depot V2, push this in as close as we can get it right here. This can go... We'll delete this because this needs to become multi-rail. Because we're going to dispatch this to more than one location now. We'll make this a 5. We'll make this the first output. This will become a 5. Actually, do I want that to be the first output? This might need to be the first output. If we put this forward one, this can become output number 1. This can become output number 2. There we go. We'll bring that to there. We'll get that set up. Let me just dump in plastic dust. We'll put these 4 back in. There we go. Now these machines can continue making plastic dust in the background so that we have some built up for when the main event occurs. When we're pushing towards our final product domes for Selenian. So let's copy this. We'll put in one more multi-rail 5 right here. Bring rail 2. Blah. Auto-saving. We'll bring rail 2 forward. Into here. We'll call this plastic dust for scaffold. I'm not sure why scaffolding would need plastic dust exactly, but hey, I'm not going to argue it. So there we go. And that should be all of our ingredients, right? Let me just drop down a constructorizer to double check before we run off. We're going to be making scaffolding? Oh, scaffolding was the one that we got for free with the constructorizer. So yeah, it's got uber filament. Oh, there's a hidden... Wait, why is there a hidden? I missed one. Reinforced frame, which is fine. We have reinforced frames on tap back at the back at our Mega Press base. So let's go back there one more time. We'll set up reinforced frame dispatcher, and then we'll be ready to go. See? This is why we double check. Okay, here's my Slapdash V2 storage depot for reinforced frames back here at the Mega Press base. So we do have one extra output available right here. I guess I can stick another one of these on... How is that colliding with another building? Is this... Oh, this is one too tall. If I bring this down... Let me just double check. This is gothite lattice for scaffold, right? Gothite lattice for scaffold, yeah. So if I drop this down one, I should be able to put another one directly on top of this. Right here. Now, before I put that in there, let's make this gothite lattice. Gothite lattice so I can dump these back in here. There we go. We'll do G lattice for scaffold one more time. Now we can hook this back up. Now I can put another one of these directly on top, facing this way. There we go. We'll grab our extra output from here. We're out of juice. So I'll put... Actually, these are 200 each, right? So if I delete this, there's 200. There's 200. This is 400, so this is the equivalent. But producing way, way more power. We are still going to need Where's the base core? Is this one? Is it? It must be. We're gonna need one more base core amplifier. There we go. Make sure this doesn't overlap with anything else. I would hate for one of these factories to be sitting idle because I accidentally pushed one of the thermal bits over. Not sitting idle, but, you know, waiting to cool down after a rupture. Okay, so let's get actually back up here, not building anything. Let's get up here and set up this dispatcher. This is going to be reinforced frame. This is R frame for scaffold. There we go. Okay, now we have everything we're going to need to produce scaffolds. So let's get back to our Selenian base. So we know we're going to need 4 cargo receivers, 1 for each material, and we're also going to need 3 constructorizers, which are fairly large, if I remember correctly. They're not very wide, but they are rather deep. They are fortunately the same length as our compounders, but I did not leave myself any room for pillars in between these compounders, so we'll probably have to set these on a new row. So let's start off by setting up 4 cargo receivers. We'll go as close to this as we can. We'll space this by 1, 2. And I guess let's go 2 more. 1, 2, because we're going to want to feed from the back. We'll buffer from the back like this. Here's 1 and 2, and what I'll probably do is bring these up. So let's go 1, 2, 3, 4 pillar supports. 1, 2, 1, 2, 1, 2, 1, 2. Platforms on each. And then we can do another set of these here, just to condense this a bit. So these will be our 4 incoming materials. Like so. We'll hook up our rails for these. 1, 2, 3, and 4. And before I set up the rail distribution for these, I want to look at our ratios to see if we're going to be able to fit all of this onto one rail or if we're going to break this into multiple rails. So let's put this 1, 2, and 3. And let's see, is this enough space to put one? It is. Okay, so we can put a second set of constructorizers on top of this. So if I set this to produce scaffolding, this is 2, 4, 5, and 6 times 6. So 6 and 6 is 36, so we'll definitely be able to fit this onto a single rail. So let's drop supported platforms at the corners of these just to bring our power through. We know we can combine all of these onto a single rail. 1 and 2, then rail modulators for 3 and 4. Like so. Join it up, and then we'll do 1 additional. Oh, I put these too far back. No! Whoops. There we go. Push forward by 1. Now we can bring our rail through. We're going to do a rail modulator here. Is this going to be far enough forward? That should be okay. To bring this and this together. And we can flip this around. Oop. Lock our Z. 1, 2, 3. break one of these off into each constructorizer. I almost want to bring these down a couple levels just so this lines up a bit easier. Or not easier, but more appropriate height for going into this so it doesn't have this weird down curve, but it's fine. That's just being too picky. Alright, we'll bridge this gap right here. And that should be everything that we need to be manufacturing scaffolds. Although we do need to bring our individual ingredients in, right? So we're going to have Gothite lattice for scaffold. GLTTC for scaffold. We're going to have plastic dust for scaffold. Plastic dust for scaffold. Yeah, that's fine. Up here, we're gonna have R frame for scaffold, R frame for scaffold. And then finally, Uber filaments for scaffold. Okay, let's set our outputs. Uber filament. This is reinforced frames. This is plastic dust. And this is gothite lattice. There it goes. We'll set these to scaffolding and scaffolding. And we're manufacturing scaffolding. So this is 10 seconds. That's 6 cycles per second. Only 1 per cycle. So this is 6 per minute times 3. That's 18 total per minute. Wow, it's been 40 minutes already? That's crazy. Let's bring these together into... I guess we'll do it on this end. So let's bring this up. 1, 2, lock our Z. Switch to a rail modulator. Flip it this way. And then 3. Bring our rails through. Like so. We'll bring these into a storage depot V2. Right here. Rail support. Let's do it into the side again so that we can use the forward-facing 3 outputs to go into dispatchers. We'll set this to collect scaffolding. And there it is. Okay, let's get to safety, and then we'll work on our next item. So the next item's manufacturer on the dome path is going to be airlocks. Airlocks are going to require 4 inputs. Right, 1, 2, 3, 4, yep. 1 is going to be Uber filament, which we already have in the factory, so what we'll probably do is just extend our rail from our scaffolding factory into our airlock factories to let those Uber filaments continue through, or just tee off the output from that cargo receiver and then feed that extra feed into the airlock assembly line. But Uber filament, we're going to need pseudo-rubber insulators, which we're going to have to set up a new dispatcher for. We're going to need scaffolding, which is in that same factory. And then way down here, we have pressure tanks. So pressure tanks, I think it's also in the assembler factory. We'll need to set up dispatch for 3 per minute of those into a single constructorizer manufacturing airlocks. In our assembler factory, we have pseudo-rubber insulators in this storage depot V2. And pressure tanks are down here. As you can see, I've upgraded this to a storage depot V2 as well. So we have plenty of these laying around. I just need to filter them into dispatchers. So we have 1 extra output on pseudo-rubber, and we have several outputs available on pressure tanks, so it should be relatively simple. I just need to find some space for it. What I'll probably do is bring another pair of excuse me, bring another pair of pillars up in the back of this last dispatcher. Lock our Z. Bring this up by 2 pillars. Copy. Lock Z. Lock Z. Paste. We can bring another rail out directly into here. Perfect. Set this up. This is going to be pseudo rubber insulator for airlocks. Airlock. Pseudo rubber insulators. Perfect. And then our pressure tanks. Copy this. We can put this one, I guess, directly behind. Yeah. Rail out into here. I don't think there's anything special. Yeah, there's not enough room. Well, I guess there's technically room, but this is fine. We'll just do it on this side. This is going to be P-tank for airlock. Pressure tank. And then we had Uber filaments and scaffold, right? So this should be the only 2 new dispatchers we need set up. So for our airlock factory, we only need 2 cargo receivers. So we can actually build this out over the top of some of our existing constructorizers because we only need 1 constructorizer. Let's flip this around and we're going to have to bring up some additional pillars here. Please. There it is. And bring these. Why is this like this? I'm not. My Z's not locked. Where are my pillars? Where's my pillars? What is going on? Whatever. That works. Cap these off. Let's bring in another cargo receiver to the left. Auto saving. There we go. 1. And I guess we'll do another one right here. It's a little awkward. It's gonna do this thing again. It won't let me put it directly on top, but if I point it at the ground underneath it, there we go. I can adjust the Z until it's where it needs to be. 1 and 1. Yeah, we just need 1 constructorizer at the end, that's fine. These are spaced a bit further out than necessary, but it's not the end of the world. Storage depot, let's lock our Z. We can put 1 here, and we can put 1 here if we put some supporting platforms. There we go. So this will be for pseudo rubber insulators and for pressure tanks. And then Uber filaments is right here, so we can actually bring this forward. If I put a rail modulator right here, I can bring out whatever's going to be in this storage depot and whatever's, or and our Uber filament. There we go. And then our scaffolding is right here, so what we'll probably do is just bring this up because our constructorizer is going to be right here on the end. We'll put a supported platform right here, bring this up 1, 2. It should be the exact height needed for a constructorizer. Right there. We're over our power budget, so I'll probably convert this. The problem with making these all level like this and using all the vertical space is that you create walls of rails. Let's kill this. Let's turn this into a chemical generator. There we go. Now we can work on our rails. So let's get rail modulator. Lock our Z. We want to bring this way, and then we want to bring a rail support, say, here and here. If we put this diagonally, this rail support diagonally, we can get a satisfying curve. When we do this, and then we can bring this into here, this into here, bring our rail forward, join it, and there we go. Let's get up top. Let's set up our receivers. P insulator for airlock. This will be P insol for airlock. Set this to pseudo rubber insulators. This will be pressure tank. P tank for airlock. P tank for airlock. Set this to pressure tank. Uber filament we know is already on the rail. And scaffolding doesn't need, well, it is buffered already, but it'll come straight up here. Nothing else to do except set this to... Oh, we have to unlock the recipe. That'd be a good start. Right, airlock. I'm gonna drop a habitat with an airlock, which is the thing that we're making. This is the thing that we're making, I guess. We need a recipe station. And to unlock the airlock, we're gonna need 200 pseudo-rubber insulators, 600 scaffold, 300 pressure tank, and 400 uber filaments. Let me go scrape those off the line. Okay, here's our parts. Constructorizer, airlock, we have 200 pseudo-rubber insulators, 600 scaffold, 300 pressure tanks, 400 uber filament, and 6,000 data points. Unlocked, ready to go. Let's delete this. We already have everything set up. We just need to get up top and set our recipe to airlocks. Here it comes. Om nom nom. And we're making airlocks. We're actually making more airlocks than necessary. This is 12 seconds. That's 5 cycles per minute, and I believe the endgame domes only use 3, so we're overproducing with a single machine. But let's collect these airlocks into some kind of depot. I don't know if we'll need a storage depot V2, but it can't hurt to have it. You can never have too many of an item. Well, I guess technically you can. You can have, once you've turned in every item, then there's really no more need for items. But you can technically have too many, but I guess you could always just turn them in for brownie points from the corporation. Like a good little debt slave. So we'll bring this rail down. And we'll collect this into here for now. We'll have to set up... Well, maybe not necessarily. Well, probably, because I don't know if we're going to be able to fit more than maybe one more factory in here, depending on how wide it needs to be. Because we need to make condensers and converters and then domes. So we're getting there. We have two more materials yet to make. Our next material that we have to make is condensers, and I think we've actually already created condensers in the past. We had to create condensers to turn into future health to unlock access to powerium, I think. So we'll obviously already have everything that we need to make this. We're going to need resonators, which we have, nanofiber, which we just created earlier. We're going to need pumps. And just those 3 things. Okay, so what I think I'm going to do is I'll put this assembler, or these 2 assemblers, in our assembler factory rather than our new factory. That'll leave us room to put in our final 2 facturers here for converters and domes. And also because these condensers are going to be used in another factory later on to make rocket engines for Clever Robotics, I want to say. So if we get these set up in our assembler factory, we'll have more room for them, and we'll have some more room to dispatch them to another factory later on. So let's head over to that factory. So here in our assembler factory, the first ingredient that we're going to need is our resonators, which I actually also forgot to put into a V2 storage depot. So I'm going to delete this and see if we can squeeze in a storage depot V2 so that we can be building up a collection of these. Building is sliding. There we go. That'll work. We'll bring this directly into here. We'll reconnect this. Actually, if we put another dispatcher in right here, we can convert this to multi-rail. Let's lock our Z. We'll bring this into here. We'll bring this into here. One out. Then we can put another dispatcher right there. But first, I want to put this into collect mode for resonators. We'll dump these in here. That way this one assembler that we have making resonators can get back to work and earn its paycheck. Earn its keep, I guess. We're not paying these guys. Let me up. If I'm not getting paid, they're not getting paid. So we just squeeze another one of these right next door. We might need another support. Nope. This is a bit awkward, but I don't care at this point. We don't get extra points for style. The corporations just want their products. So, over to the dispatcher. This is going to go Reso for, we're making condensers, right? Condenser. Confirm. Resonators. There they go. And we're going to need to go to Mega Press Factory for pumps. Let's head over there. And our pumps should be right in the front. We just looked at these earlier. Yep, so we have plenty of room available to set up another cargo dispatcher. Where are they? Oh, we're not even dispatching these, I don't think. Wait. No, we are. They're going to here. So I guess if we wanted to keep this in line, we could put this here. Climb another building. Really? This be the exact same height? This deck is the same as this deck. Why does this fit here but not this here? That doesn't make any sense. I guess it's one of those things where you have to place the bottom one first and then the top one. Yeah, because look at the yellow bounding box. Whoa, these things want a crazy amount of space on top if you don't build the bottom one first. Anyway, that's fine, because we can put this over here somewhere. We'll put this here facing this way. And we'll just grab off of this into here. We'll set this up as pump for condenser. Pull in our pumps. There we go. So we're going to set up one more assembly line at the far end of our assembler factory. Let's lock our Z at this level. We're going to bring this out 1, 2, and align this with this. I guess we'll go forward from here, right? So we'll do cargo dispatcher, then our storage depot right there, and we'll continue down this line. I don't want to intrude on the water. We'll just go this direction. So we have 3 ingredients, right? Resonators, pumps, and nanofiber. And I think we already set up a dispatcher for condensers from our nanofiber factory. I just got to keep an eye out for vermin around these parts. Or an ear out. And they'll let us know when they want attention. So here's our 3 receivers. We'll set these up for nanofiber for condenser. Nanofiber for condenser. We're gonna have pump for condenser. pump for condenser. And then resonator for condenser. Reso for condenser. Resonator. Pump. Nanofiber. 2 assemblers. Facing this way. 1, and we'll space this out 1 more. I don't know if we'll ever need to put anything on top of this, but if we do, we've got the space for it. Start on the end. Rail support. Rail support. Then modulator. 1 tooth. Flip it around. Modulator. Bring all of this together. Oh. There we go. Sometimes it just doesn't want to connect. Speaking of, there they are. Well, let me just finish this up. There we go. Just connect this to some power. Supported platform. We'll put this right here and here. Perfect. There's our drones. We have condenser and condenser. And again, we don't have to unlock this recipe because we already made these earlier in our playthrough. We're condensing. This is a 15-second manufacture time. So we should have no problem condensing these onto a single rail. Like so. And we'll set up a depot V2, which will probably be overkill. We're going to collect condensers, and then we need to send this into 2 dispatchers. Although, well, it can't hurt to do it this way. But since these will never be made at the same time, because Dome is the final product for Selenian Corporation, why don't I do it like that? And then Rocket Engine is for a completely different, that's for Clever Robotics, so we'll never have these 2 dispatchers running at the same time. So I could technically, down the line, just go and reconnect this single dispatcher to a receiver in another factory, but it's not that big of a deal. Actually, yeah, let's spin this around. It's not that big of a deal to just set up 2 dispatchers and then never have to think about it again. Let's spin them around like this. And then we can keep everything on the same line. We'll put a multi-rail here, here, and I guess here. We'll take... Where can I fit this? This will go here. This will go... Ooh. Give me this. Put this on the first rail if we can. 1, 2, there we go. And the second, so that this can go to here. And this will go all the way through to our last dispatcher. And then we're going to have condenser for Dome. Condenser. And then condenser for Rocket Engine. Condenser. There we go. I'm not quite sure what a Dome is going to be doing with a condenser, but we've got the condensers for it. So let's head back to our Selenian factory because our final 2 ingredients are going to be made in facturers on site. Let's slap down one of these facturers before we start planning this factory out. Let's take a look at the recipe. So in the facturer, We're going to need to be making converters first. This is going to require 5 inputs: laser emitters, accumulators, electromagnetic coils, plastic, and RTSCs. We're already manufacturing all of these, but we do need to set up dispatchers so we can bring them all here. So these are made pretty much everywhere. So we're going to have to go on a little field trip to hook all of these up to dispatchers. But I guess let's start at Atlas Field because we have 2 in that location. Okay, here in Atlas Field, we have our laser emitters are going into laser emitter TX1. And if I remember correctly, these are just going over to the production of RTSC generators. Yeah, so here's laser emitter TX1 going into storage depot, going into RTSC generators. So this factory will never need to run again. So rather than setting up a second dispatcher, we can just steal this. So we don't have to unroute this. What we'll do is we'll just drop down a new cargo receiver at our converter factory and then just steal that active connection. And I think it's going to be the same with our RTSCs. These RTSCs are not hooked up to a dispatcher at all. They just go directly into this assembly line here. So I can put a dispatcher on this. Maybe right here where we have this pillar support already waiting for us. I think that used to support a orbital cargo launcher. It's now going to support this dispatcher, which we're going to use to dispatch RTSCs. RTSC for converter. Okay, there's 2 of our ingredients. Our plastic production is actually in our compounder bay, not in our assembler factory. So here's our original plastic storage depot and our new V2 storage depot for plastic. This is going into a pair of dispatchers, so we'll just add a 3rd one here if possible. We might not have the height, considering we have to build these bottom ones first, or it wants like some ridiculous number of vertical offset. So we can put this, I guess, in this direction instead. We'll put this right here. And we'll take a single output from this side of our plastic depot. We'll call this plastic for converter. Pull down plastic. Okay, there's another ingredient. Accumulators are in our assembler factory. We have our original V1 storage of accumulators, which is now in line with a V2 storage depot. So I'm going to grab just an output out of the side of this V2 storage. We'll rotate this in whichever direction. There we go. We can squeeze it in right there. We'll set this as accumulator for converter. And there's another one. And finally, we have electromagnetic coils at our plateau base, which was the entire purpose of this whole factory. So this should be easy enough to just stick another one of these dispatchers on the end. We'll take one more output from the side into our multi-rail, bring it all the way down. Put another multi-rail support. Feed this in. There we go. And this will be E-coil for converter. Set this to electromagnetic coils. All right, we're ready. All right, back here at the Selenian factory, we're gonna need 5 receivers for this next factory recipe. Everything's gonna need to be piped in. So let's grab cargo receivers. We'll probably do this setup again where we have double stacked, because we're rather short on space. Let's go out 1, 2, and then another 1, 2. And we'll buffer in the front storage depot, like so. We'll press these together. And then bring it up with supported platforms in these locations. Unlock our Z. Bunch of pillars. A few platforms. Then we can bring these up. Relock the Z. 1, 2, 3, and 4. Rails out. There's 4 of our 5 ingredients that we need. We'll have one more down at the bottom. Five in all. And then we're going to bring these when we're done autosaving. We're going to bring these into a facturer facing this way. It's going to spit out over the ledge, but that's okay. These things are deep. It's because I put them in the wrong spot. Facturer goes here. There we go. Actually, you know what? We have 2 facturer recipes we need to make. Where'd it go? It's over here. We have 2 facturer recipes left. We have this and then the domes themselves. Domes require another 5 ingredients. Uber filament we have here. Condensers we'll have here. Airlocks we'll have here. Scaffolding we'll have here. Never mind, everything is going to be here. But we may end up dispatching it. So I think what I'll do, just to be on the safe side, is let's just double stack this. So let's have 5 receivers in a row times 2. So we'll keep this, but we'll just keep expanding it. So we want to do 1, 2, 3, 4, 5, and then our facturer here, right? I didn't get myself a safety spot, but I don't think we're going to need it. So let's put in storage depots like so, and then we'll just continue this layout all the way down. Here's our pillars. Slap down some more platforms. Right, 1, 2, 3, 4, 5. Perfect. We'll bring this up. Lock our Z. I don't know if, well, plan first, fix later, right? We'll bring this up. 1, 2, and 3. I'm not going to worry about these for right now. We're going to just hook up the rails up for this bottom rail, or for this bottom factory. Then we need these last 2 here and here. There we go. We're right on the edge of our thermal capacity. We have 1 left over. Let's see if we're going to have enough power. We should. We have a whole chemical generator working here. So if we put this here, there we go. We're online, although I'm going to need that spot anyway. So let's see, delete that. When we run our rails, we'll end up having something in that spot. So let's lock our Z. We're gonna have 1, 2, 3, 4, and then rail supports on the ends. Like so. Run a rail through. Merge everything together. Into a single rail. Because this manufacturing is so slow, we're not going to be exceeding our rail capacity. Right to the center. Let's get these pulled in, and then we're going to need to borrow from this to unlock this recipe for converters. So let's start down here on the end. With accumulator for converter, accum for converter, Set this to accumulators. Next up, E-coil for converter. E-coil for converter. Set this to E-coils. Plastic for converter. Plastic for converter. Plastic. RTSC for converter. RTSC for converter. Room temperature superconductor. And then, what was the last thing? Oh, we needed to borrow laser emitters, I think. Let's look at this one more time. Converter, yeah, I have to steal laser emitters. We're gonna take our in-use list and grab laser emitter TX1. There it is, laser emitter TX1. Yoink. Laser emitter for converter. Set this to laser emitters. We can't set the recipe yet, so let's drop down another hab. Somewhere. I don't really have any room for anything else. Habitat. There we go. Put an airlock on there.
Is in its stable stage. Deployment of Arcadia is returning to normal.
So, for unlocking converters, we're going to need 800 plastic, 100 laser emitters, 300 RTSCs, and 600 electromagnetic coils. So, let me go grab those. Alright, let's turn it in. Facturer, converter, 800 plastic, 100 laser emitters, 300 RTSCs, 600 electromagnetic coils, and 8,000 data points. Unlocked. And we'll leave this up because we're going to need this again when we get to domes. But right now, we'll set converter as our recipe. Here it comes. And there's our first converter. 15-second manufacture, which is slightly faster than our RTSCs, which I think were, or RTSC generators, which were 20 seconds, but this is a second from last stage manufacturing item. Because after this we have domes, but for that I'm gonna have to drop down some more base core amplifiers because we're at the literal limit of our thermal capacity. What are these things? 400. So I'm gonna need 2, 1, 2, and we'll put down one more for good measure because I do need to put some storage depots in. From here, actually it's a bit unfortunate. Our habitat is in the way of our output. So we will break that down. I'm gonna need to pull these out. I guess. I don't even know if I want to put these in a storage depot because these are going to go 1-for-1 directly into our facturer for domes. So let's bring this up on a supported platform, or I guess make supported platforms for another one on top of this. Platform and platform. Flip this around, right? Yeah. Sorry, a bunch are coming from this side. There we go. So our converters... Are converters being used anywhere else? Let's check. Converters are not being used anywhere else, so these can be dedicated to go directly in. Let's grab this way. Do a rail connector. Let's do a rail connector. That way these can go up like this. So we'll go out. Loop this up. And then we can send this across to a rail connector here. And then finally into a rail support Here should be fine. Rail. Oop. Like so, yeah. There's one of our ingredients. The rest we'll have to pull in from our receiver. So we do have one extraneous receiver, not that big of a deal. We will probably need to set up dispatchers for some of these things, although I guess we have two of our ingredients right here, so we can actually join these onto this. That's a little convenient. Almost like I planned it, so we'll bring these up to here and to here, so there's two more of those receivers that we don't need. What else do we need? Now, what do we have here? This is scaffolding, airlocks, and converters. So we need uber filament again, and condensers. Condensers. Where do the condensers wind up? Oh, condensers are in our assembler factory, right? So that we will have to. Condensers are coming in from our assembler factory, and uber filament we already have here. How much uber filament are we using exactly? 8 every 20 seconds. I don't think that's going to break the bank if I grab an output. I just need to find a way to get that rail over here. Here's our uber filament. I need to get this back here. So let's put another rail element in here. I need to get out of the way first. I need something in between these two. Probably a rail connector. We'll lock our Z. We'll intersect this on its way this way. And we'll send this back to here. So let's put a rail connector here. I don't think we're going to be able to get from there to here. So we'll put it here. Can we do this to this? We can. Okay. So we don't need one of these. We'll bring this straight through, rail modulate this. We'll bring this to here. And then rail support. Oh. Lock our Z right here. Like this. And then this will come out of here. We'll set this up to bring in condensers. Condenser for dome. Condenser for dome. And yeah, our other ingredients are already here in the base, so there's a whole lot of receivers for nothing. It's just there for symmetry, we'll say. I do need to set this to... Oh, I didn't connect this. I need to connect this first. And then I can set this to condensers. There they go. Okay, so we just need to unlock the recipe, so now I have to put down another hab. And we'll take a look in Facturer. And for domes, we're going to need 500 scaffold, 300 converters, 100 condensers, and 300 airlocks. So, let me go grab that off the line. Okay. Last turn in Facturer. Domes. We have 500 scaffolding, 300 converters, 100 condensers, 300 airlocks, and 8,000 data points. That's it. We've got the whole Selenian Corporation track unlocked. Let's kill that. Let's get up top. Set our recipe to domes. Wait for things to trickle in. And we're manufacturing. But we can't turn these in just yet, so I am going to collect on the output of this. I guess we'll do a single storage depot, though we need 1,000 of these, right? So I guess I'll do a storage depot V2 here. And do we want a separate one? I mean, we might need to turn in converters to Selenian Corporation before we get to this point. But for now... we can run these into here. We'll have this collect domes. There they go. Very tiny domes. I don't know, are these domes for ants? Who's gonna live in these tiny domes? But there we go. So now we're manufacturing everything we need for Selenian Corporation, but we have to work our way back up, or continue our way along the Selenian Corporation corporate ladder. So let's plop down an OCL and take a look. So for Selenian Corporation, rank 13, we need converters and airlocks for 847k. So I'm probably going to turn this back off because we're going to need all of these to go to this turn-in. So let's get back up here. Let me turn this off. And then I'm going to redirect. We can't do both, I don't think, into a single OCL. If we put this one here, we can do airlocks, and then we can... and then we can do converters from here. We'll set this to turn in Selenian Corporation converters. And we'll set this to turn in airlocks. And now we wait. Go grab a book, grab a snack, something nice to drink, and I'll meet you back here in a little while.
Congratulations.
And there we go.
Your reward, as always, is waiting in the corporate terminal.
And our reward is some quartz ore. Goody. Okay, so that took a couple of ruptures, and I did have to go and supplement our uber filament production a little bit by sticking in an additional assembler for uber filament, which itself required me to put a local source of calcium powder from a furnace V2, so we were drawing a little bit too much calcium powder. It's like 6 per cycle, but that was all set. So what I'm going to do now is... oh, I guess I cannot delete that. That's okay. We'll delete this one. We'll keep this one in place. Let's get rid of this. And we'll just route the output of our facturer over here. That way I don't have to delete my hab. Let's get up here and turn this back on. Power this back up. So this is a 20-second manufacturing time. We need to make 1,070 of these to fulfill our... should be 1.07 if it's the same as... yep, Moon Energy Corporation. So at 1,000 per dome, which I haven't actually turned on yet. We'll have to go turn that on. Right here. Give me back some airlocks. Selenian Corporation. So at 1,000 points per dome, that's 1,070 domes we have to deliver. Let's do a little math here. 1,070 times 20 seconds, which is our manufacturing time, and also the exact amount of time it takes for a cycle of the OCL to go through. That is 21,400 seconds. Divide that by 60. That is 356 minutes. Divide that by 60, we have 5.9 hours for a single facturer to complete the turn-in for a level 15 corporate request. So basically, it's going to take 6 hours to turn this in, much like Moon Energy Corporation. So I think that's what we're going to call it for this episode. So what I think I'll do is what we did for Moon Energy, where I'm going to let this run in between episodes, and I'll just run this on the side over the next couple of days and deal with any item deficiencies that happen to pop up. So we'll call it here, but first let me turn off the UI, and let's get up here and take a look at this Selenian completion factory we made here. Not too many lines. Again, we only needed to create 5 items in order to get to domes and do our final turn-in for Selenian. But this does bring our total number of items in the game that we have yet to manufacture down to 19. So we're almost there. But yeah, there we go. So, if you're still with us, thank you for watching. If you're enjoying this playthrough of StarRupture, hit like and subscribe. If you want to check out StarRupture for yourself, head on over to Steam and pick it up. And if you want to let me know what you think of the game so far, then hit the comments down below. But whatever you do, I'll see you right here again in the next one. So, until then, bye-bye.